Travis Gillespie here, and we're going to look at functions and relations today, and I'm going to show you various ways to represent relations. You know, a relation, all that it really is a connection or connecting of two quantities. And here you see within these wacky brackets, these set of numbers here, I've got a relation of two quantities connecting. 1 and 10 are connected somehow. 2 and 8 are connected somehow. 3 and 6 are connected. However, 1 and 10 is not necessarily related or connected to 2 and 8. I don't know that from just a set of numbers. Um, but a relation, again, it's connecting of two quantities, and that absolutely is the key to advanced mathematics, to be able to connect two quantities, to be able to connect 1 and 10. So what we're going to do is look at different ways to express this. So here I have a set of numbers. The numbers are within parentheses and the parentheses within brackets. So this is a set within brackets. The second way to look at to represent the same set of values is through a table. I'll draw up a table here, get a line going down the middle of it. Alrighty. And now we'll start to write in the values in a second. First thing I should probably label are my x values here, my y values here. And I could probably even highlight that a little bit more. Nope, that didn't help out. But highlight it with a darker color. Should help it out. So here's my, nope, don't like that either. Okay, just stick with this. And I'm going to create 4 cells now. Going in, you could say, well, my first set is a 1 and 10, so my x values are going to be 1, 2, 3, 4. These are my inputs. My x values are inputs. My y values are the outputs. So my y's are the 10, 1 and 10, 8, 6, and also 4. And this is a table. Table captures the exact same relationship as the set above. However, it's not the only way to represent these values. I could also create a map. And what I'll do here is create 2 separate sections, and let's actually copy that and recreate it again. Cool, it's a different color here. That's pretty neat, but I don't want a different color. I want the same color. Go ahead here and create our map. And mapping, really, it's a way of looking at kind of a futuristic or a future type of map where my x values, I'll call these my x's, these my y's, change the color and just say, hey, my x's are going to map to my y's. Just create 4 of these here. Go back to a green here and just say, okay, so for my 1, 2, 3, and 4, my 1 is going to be mapped to 10. My 2 will be mapped to 8. My 3 mapped to 6. And 4 mapped to 4. So here's a mapping way of representing the same set of values, or the relationship, or the relation. Now there's another way to represent this. I'm going to move the screen over some, and it's through a graph. And we'll go back to the green. And by graphing, my first set, or first coordinate, will be my x value. And my second will actually be my y value. So if this were my graph here, I were to say, hey, this is my x, my x down here. So we've got my 1, my 2, oops, created 2 2, my 1, 2, my 3, my 4, and also again. I can make each of these worth 2. So 2, 4, it looks like a 9. 4, 6, 8, 10. I really don't need this top one, but I'll still make it 12. Now let's go ahead and plot these points. Well, my 1 is actually related to or connected to 10. So I have a point up here. My 2 connected to an 8. My 3 to a 6. And my 4 to a 4. So now notice these discrete points. This is a discrete graph. I don't connect them because I don't know any of the other points. I don't know that they're connected to each other. These other points I have no way of knowing they are. So these are all different ways to express relations. I could have a set of numbers. I could have a table. I could use a map or a graph. Neat. The cool thing about the graph is that it's also a geometric way of viewing or thinking about our set of numbers. We can visualize it. And to be redundant, just to state it again, this is a discrete graph because I don't know any way of knowing the other points are connected to each other. So all I do is I report 1, 2, 3, 4 points, 1, 2, 3, 4 points, 1, 2, 3, 4 points, or again, discretely 1, 2, 3,